So now when we have already studied deviation, and if I have to write the points or the factors on which deviation depends, so we are writing factors on which deviation caused by prism depends. What are the factors you should write? Obviously the refraction thing has to be taken into consideration, but do you think that angle of prism takes a part in this? Yes, because okay, first of all, what is angle of prism? I have already mentioned it before, but I will repeat. Consider these two diagrams. Here this one is 90, here this is 60. So angle of prism is a property of prism by which we can classify what type of prism it is. This is an equilateral prism, this is a 90-degree prism. So angle of prism is this angle. Okay. When you will be going to higher classes, you will be studying a formula that I plus E is equal to, I said E. So I plus E is equal to delta plus A. What are these terms? This is angle of incidence, this is angle of emergence, this is the angle of deviation, and this one is the angle of prism. So this is basically a relation of deviation produced by prism. I plus E is equal to delta plus A. So that means delta is I plus E minus A. So that also means delta is depending on angle of incidence. Then see, angle of emergence is something which is depending on the angle of incidence. Lesser or more the angle of incidence will consequently change the value of angle of emergence, but I is the key factor here, whereas the angle of prism also is key factor here. So factors on which the deviation depends are, first of all, angle of prism, second one is the angle of incidence, and the third one, what if the ray is coming along the normal? We have done this part in the total internal reflection thing, TIR part, where we were seeing that how rays are refracted or reflected 90 degree or to 180 degree by just using a simple prism, because critical angle was about 42 degree. So angle of incidence, yes, it is a depending factor, and lastly the material of prism, because even in the case of glass, the glass is like flint glass or Tron glass, so the type of nature of material will be changing the extent up to which the light is getting refracted. That means we are talking again in terms of angle. So these are the factors on which deviation depends. Now there is a very key point which decides how much light will be bending. The key point is that the wavelength and refractive index of the glass. So what do we know about relation between wavelength and refractive index of the glass? See, there is a very solid relation that refractive index is inversely proportional to wavelength of the incident light. What does that mean? Suppose we have a refracting surface and I have got a light ray incident at this angle, and this is our normal. Okay. Now when the light ray is coming, according to the normal theory which we have read, instead of going straight, it is supposed to bend towards the normal, right? But if this light is of very higher wavelength, it is going to get refracted very less. That means it is not going to refracted more towards normal, it will be refracted very less towards normal. But if the wavelength of light is very less, it will be offered very high refractive index. That means a very large bending will take place, due to which it will suffer very more bending towards the normal. So now you can see the difference, a lower bending and a higher bending, because of just change in the wavelength of light. So what you have to remember, a key factor in deviation is the wavelength of, include this point also in the deviation factors, the wavelength of incident ray. This will be the fourth point. Okay. So because, and or you can also write this in bracket, that refractive index is inversely proportional to wavelength of the light. And now we are going to proceed into what is dispersion.